Hello everyone, welcome to the online lecture series of the course EE204 Digital Electronics and Logic Design. Module 4 Sequential Circuits and Asynchronous Counters. In the last few video lectures we have seen the different types of shift registers. In this class we will be studying about the detailed working of a PISO shift register, which includes some logic circuits along with the basic flip-flops. As you know, a PISO shift register, the input to the shift register will be provided parallelly, whereas we need to obtain the output as the serial form. So this is the basic circuit diagram of a PISO shift register, which is used to load the data parallelly and to shift the data serially as required. From this figure, it is clear that the gates G1, G3, G5 and G7 are provided with 1 bit of the input data as their input, and the second input for this gate is from the complemented form of the load shift line, which means if load shift line is having a value 1, the complemented signal line will be having 0, and if load shift value is having 0, then the complemented signal line will be having 1. So these gates are provided with the input data bits. So this is to load the data. So in order to load the data, we have already seen that we have to make this load shift line to 0. If load shift line is 0, then the complement line will be having value 1. G1, G3, G5, G7 are AND gates, and if one bit of the AND gate is 1, then the output will be purely depending upon the second input. If input is 1, then output is 1, and similarly if input is 0, correspondingly output will be also 0. Similarly, the gates G2, G4 and G6, one input of these gates are connected to the load shift line directly, and the other inputs are connected to the first, second and third flip-flop respectively. If load shift line is having value 1, then these gates will be providing outputs according to their second input, that is nothing but the output of the flip-flops. Since the load shift line will be having one value at a time, the gates G1, G3, G5, G7, all the odd numbered gates, or G2, G4, G6, all the even numbered gates, one of these sets will be working at a time. For inputting, gates G1, G3, G5 and G7 will be working, that is only for the first clock pulse, and for shifting the input data, gates G2, G4 and G6 will be working in the remaining 3 clock pulses. Now let's start the simulation of the same circuit. Let us assume the parallel data we are providing is 1001. So in order to load the data, the load shift line is made low. Then apply a clock pulse. In the application of first clock pulse, the last flip-flop you can obtain the corresponding output data bit. The last data bit you have inputted is 1. So that is obtained as output for the first clock pulse. Now change the load shift line to 1 and apply 3 more clock pulses. On the first clock pulse, you will obtain the next input data bit, that is 0. On the third clock pulse, you have obtained the third data bit, that is again 0. And for the fourth clock pulse, you have obtained the fourth data bit, that is 1. So on each clock pulse, we can obtain the next bit of input data in the serial form from the last flip-flop output. At the end of fourth clock pulse, all the 4-bit data entered parallelly to the shift register are obtained in the serial form from the shift register as output. So I hope with this explanation you are familiar with the working of a PISO shift register.